Hello everyone, thank you for being there today. Hello Michel. So I'm Aurélie Baker, I'm the EWB Sud France manager. And I'm really glad today to welcome Michel Seyrac from IIDRE. IIDRE is one of our alumni, and we decided recently to run a series of webinars to highlight our alumni. The EWB Sud France the 8 years this year, so we have a lot of alumni and we are very proud of them, and we decided to have some time to let them the floor to explain what they are doing. So today we are very glad to talk about IIDRE. So Michel, I give you the floor.
Thank you, Aurélie. So welcome everybody. So I'm Michel Seyrac. I'm the IIDRE founder. So I will talk to you about geolocation today, with or without satellite coverage. I will talk about the seamless continuity between outdoor and indoor. And of course about technology. It's important to talk about that. So I propose a short summary, this one. So I want to talk, of course, about EWB ultra-wideband solution, the rupture, because there is a world before and the world after. I will talk about the indoor positioning system, how does it work. Of course, it's important to focus on the technical part, with the state of the art as well, and of course come back to the GNSS story, and the incubation, ESA incubation in 2014-15. Here my summary. So first question is, why indoor positioning? What we can do now, what is ultra wideband, what is the rupture? So we can consider that we have before and after this EWB ultra wideband solution. This solution is very high technology, completely dedicated to this indoor position. And we will see how to reach the accuracy. Outdoor, we know about GPS RTK, the centimeters outdoor GNSS, and we want to compare what we can do indoor, with this kind of technology outdoor. So we will talk, of course, about accuracy. I will say the accuracy or precision. I will explain how does it work, of course. So why indoor position? Of course, we know about the GNSS global navigation system. So we can talk about, of course, GPS, GLONASS, the Galileo solution, a European solution, and the Chinese Baidu. That is for outdoor, so we can have really accurate. We will talk about what we mean by accuracy, but we have a complete solution with, of course, smartphone on every type of technology, and thus indoor. That must be the thing, to have this seamless continuity. That means that thanks to the software, to the electronic design, the research that we done, we develop a tailor-made solution for the location with this mandatory criteria: precision. That means that we will focus in application where the precision is quite important. So ultra wideband, or UWB, is radio technology with a very low level energy. That means that we can have, with this technology, with this specific spectrum, we can have an exchange, a communication, and we deal with this. And it is very now common, because Apple already launched the first smartphone with the EWB, the iPhone 11, the 12. Samsung already have this technology, and of course all the other. That means that just the beginning for the smartphone. So why indoor? Of course, so we will focus completely in indoor. We offer a decimeter. We want to talk about centimeter, of course, in a laboratory. That means that we have it. We touch around 3-5 centimeters. But in real life, we will see that we are more close to half meter. So this technology, unlike the traditional technology, operates time of flight. That means that before the technology used received signal strength indicator, I mean the RSSI indicator is for the power. If you receive more power, that means that you are close. If you receive less, that means that you are faster. So that means that with the power, we can have algorithm to measure the distance. With the time of flight, we don't have this specific technology. Is quite different because we have, even if we have something between the two devices, we have the time of flight. So we can measure it with the speed of light. So we send a hack, we send a pole, we have a hack, and we can have the calculation. So it's come from, of course, space. It comes from space. So space agency already spend time about this technology. So if you look in research, you can find a lot of documentation about the EWB. So it's not a new technology. It's done maybe more than 10 years before. So now it's time for the applications, but the technology comes from research, of course, and it's not a new technology. It's just now complete with algorithm to have our own application. So what we can say about the EWB structure? So it is at the beginning, we have plenty of company working this kind of technology, but we can see now in 2021, in 2020 already, that the rule is already done. That means that this technology now come from chip. The chips come from decawave mostly, and ST Microelectronics is ongoing to provide this technology too, and NXP already work in EWB for the last few years, and we can see now that is already structured with a major company, and we have now consortium for consumer, consortium for car, consortium for IoT, and I want to say that the market now is declined by Gartner and by all the marketing vision. So we can have now figures regarding first the smartphone competition, because as I said, iPhone OS and Samsung already provide this kind of chip inside their smartphone, and industry that of course one of the first sector who want to apply this kind of technology. So what we provide regarding this technology at this moment, we provide three types of application. First is the tracking, so we can track. We have really a good range. We have around 100 meters. Sorry, we can have, of course, more, but to keep this 10 to 30 centimeters, the range is not after 100 meters. So we can have more, but we lost the precision. We have a consumption, of course, even if, and especially if we have in embedded systems the calculation. We need power for that, and we can provide a solution for autonomous vehicle drones to have this very precise position. We will see later the business case and use cases that we have with automotive sector. The supervision in the second case is more for asset tracking. Why? Because we can track more than 1,000 tags, and the tags just have to blink. I mean, send a beep to the all the infrastructure to say, okay, I'm here, and the infrastructure can calculate in real time the position. So we have a really good autonomy, between 2 to 5 years, but the range is less, and we have this constraint that we have to be inside the infrastructure that we deploy, contrary to the first case. And the third solution is due to this context, COVID context, we develop a distance, social distancing badge that allow to have this alert, because we have this very precise distance between two devices. We can have, of course, this log, this alert to say be careful, you spend too much time, 10 minutes in this range between 1 and 2 meters. So that can be calculated, and that's, of course, a good solution for social distancing, even if it's quite complicated, even if we have to think about the market. Is of course good to learn about the distance, but it is quite a bit intrusive, of course. So it can be, of course, a problem to deploy this kind of solution. So we already know that it's quite complicated. But we can refer to this Stop COVID solution that we already have, that we already can test. And we can compare, in this case, the different technology, of course. So it's quite difficult to have this very precise position between two devices if you don't use this kind of technology, I mean EWB. Okay, so let's talk about now how does it work. It seems to be simple, so it's maybe the best is to try to explain you in first. So 1D, we already talked about the 1D. 1D is the distance between two devices. So that means that you put two devices, and the technology allow you to have this exact distance, so that it is working very properly. Very interesting to have this information, but it's just 1D. If you want 2D solution, you need something like 3 onshore or more. That is a trilateration calcul, and with the mobile, It's quite simple. So the cross intersection of the cycle gives the possible position of the mobile. With this possible of the solution, you can add algorithm to have maybe a more precise, because yeah, of course, the radius of each circle corresponds to the range of each anchor, so that allows the measurement. In 3D, what's happened in 3D seems to be the same. We project the 2D cycle on a sphere in a space. So it's quite simple to understand. In fact, that if you want the 3D position, you need, of course, more than 3 anchors. So we have different solutions for 3D. 2D, of course, is simplest, and 1D, of course, more simple. So how it's working, on what is the difference between the application? So in technical approach, we talked before about supervision and tracking for engine, and supervision for asset tracking. So I want to talk about asset tracking. So it's a time difference of arrival. That means the time difference of arrival. That means a tag send a pole, a blink, a beep, to broadcast a beep, and each anchor receive this information and with a timestamp. And the difference of the timestamp give us the difference of the distance, and we can have a very precise position with these 3 or 4 distances. So what is interesting, of course, in this solution is the autonomy. Imagine that a tag only send a beep and after sleep and wait for a new beep. It can be done 1 per second, 10 more per second, or less, 1 per hour, and you can have, of course, really good autonomy. And we have 1,000 tags in the same time, in real time. So it's really a very interesting solution. Of course, the constraints are that the anchor in infrastructure need to be synchronized. Of course, if they want to calculate the difference between the timestamps, that means that we need a very precise synchronization. And of course, because of this synchronization, the deployment, infrastructure deployment is more complex. I mean that we need a server to have a link between the different anchors. So we have it with Ethernet, we have it with power over Ethernet, of course, and we have it with wireless. And we use Wi-Fi to exchange information. And we use, in fact, EWB for the distance and Wi-Fi to exchange the communication. The first solution, or the second solution for tracking, is two-way ranging. So we can have a two-way ranging, we can have a double-side two-way ranging, that means a double exchange. It's quite simple to calculate the position, but it's the mobile. The mobile initiate the pole, the anchor response with the hack, and we have the calculation in a tag. So it's a tag centered. That means that the tag calculate its own position. So we understand that for autonomous vehicle drones, it's a good solution to have the exact position in a tag. It's quite easy to deploy because we can calculate the distance with the deployment. So it can be done quite quite easily on in maybe something like 30 minutes. The synchronization is not required because everything is done in a mobile, in a tag. So he has his own synchronization. And we can exchange, we can have double side, we can have different calculation. The constraints is the consumption. In this case, of course, the tag calculate all the time his position, his own position. We can have something like 100 position per second to have the good precision. But of course, the device need to be maybe in a power, a big power. If you are with autonomous engine, autonomous vehicle, that is really not a problem. We have the limitation of the number of mobile as well. We cannot deploy more than 25 mobile in the same area. I mean, an area is if you have 100 meters between the range. Imagine that the area inside you can have only something like a 20-25 mobile. So I don't want to talk about all the other technology. We have the angle of arrival. We have the phase difference of arrival. We have reverse TDOA. We have plenty of other solutions. So we mixed all these solutions regarding the application or the specification that we need. And with this mix, to have, I insist that to have the distance, accurate distance, we use EWB to have the distance, and after we can use other technology, Bluetooth, Wi-Fi, to communicate with smartphone, with other. We can use LP1 technology like LoRa, for example. We can use, of course, a lot of technology, but we completely use the EWB for the distance. Okay, so I continue with the state of art, the technology review. The state of the art is from the classical technology to the more complex. Let's compare with this table. So it's actual table that we can find in the DECA website. And we compare the technology. So it's maybe a bit subjective, but it's interesting to have this comparison and maybe to discuss about it. So of course, the accuracy, we are completely proud about EWB accuracy because we are close to centimeter. It can be done as well with RFID, but RFID, the range is very close, so it's only 1, 2, maybe 5 meters. So yeah, to have this very precise position, we need to use EWB. And with Bluetooth, we know that we have something like between 1 and 5 meters, and the calculation must be more complex. And with Wi-Fi is the same. So it can be interesting, of course, to mix with the existing solution, Bluetooth or Wi-Fi, but we know that this technology is more to exchange data than to have the distance. About GPS, we can talk about, of course, the figure. We try, of course, to have less than 5 meters at this moment. So yeah, so if we compare the technology, it's quite interesting. We can have, as we see that, an exchange as well. But we know that EWB can exchange 1 megabyte per second between 100 meters. It's quite good, but we know that is really better with Wi-Fi. So we prefer use this technology for this for the distance. Okay, so that's quite simple. I come back with the competition. It's quite important because I have a point of view, of course, with other technology. So what we want to say is we are not in competition with Bluetooth or Wi-Fi or other technology, because each technology allow specific added values. So for us, EWB is distance, exact distance, and we are in competition with other solution who are providing this kind of EWB, and our partner competitor are at least, or not all, but I try to list POSIX, for example. Right? So Belgium with a high capacity, really, because we are in competition regularly with them. We know that they have quite same performance, but we can of course discuss about the ready-to-market solution. We can talk about Sevio, of course, completely dedicated to the automotive supply chain. Helico, really with very nice performance, but maybe not for the industrial market. So, and we can have this comparison between EWB only. So IIDRE is the only French with the DECAWAVE partner who are providing this kind of technology. So for us, the competition is between the capability, the performance, and the ready-to-market solution regarding EWB, and with other integrator or provider with other technology, we consider that we are not in competition. We deal with them, and we had our added value, I mean distance. So we completely adapt our solution to an existing package, just to add this very precise position. What I want to talk to you now is about the story. I mean the story, GNSS story. It's a long story, of course. And about this story, so we want to have this parallel. I mean, imagine 25 years before. Imagine the application that we can design. So 25 years before, we know that GPS is using in huge and plenty of application. So imagine indoor, we are at the beginning of the application. So I mean, we focus in industry, manufacturing. We focus maybe in other. We begin to look this other technology, other sector. Sorry, and of course, automotive sector already use the technology, but understand that it's just the beginning. The beginning, and now we are focusing at in position, so with or without GPS signal, of course, but the very precise position, the autonomy. We talk about the consumption, so we know that it can be as a GPS. You can consume much more sometimes. The target price. We are now close to the Bluetooth technology, so we can provide the tag around $10 now. So it's really new. Non-intrusive, that's quite important to talk about that. So when we work with engine, it's quite simple, but when we talk about work penability, yeah, we have to make it carefully, and of course easy to deploy. That's I think one of the most important criteria to explain that it can be deployed quite easy, depending on the solution, of course. It's not very simple, of course, but when you deploy it once, after it's done for years, and it's related to the to a cloud platform, so it has to be done once. So I want to talk about a use case, of course, a concrete case. We work for aerospace, for building sector, for autonomous sector, and what we want to provide is the very precise position. That means that for a narrow corridor, a narrow corridor is less than 2 meters. We have to deal with a cross engine, so we have to be precise. When I say precise, it's less than half meter. And of course, we deal with battery. So with engine, it's quite simple, non-intrusive or intrusive, if it's related to a human resource or not, and how it is easy or not to deploy. We can talk about other case. So imagine without the infrastructure, we can have just with mobile, we can have a calculation between the distance between the devices. So with this measure, we can have like a geolocation. So without infrastructure, it's quite new, we can have as well a geolocation. So of course, less than a complex system, but we can have this very precise. So that can, it's to avoid the collision between pedestrian and engine, for example, or between two forklifts, for example. So it's very interesting for, of course, for the supply chain sector, for warehouses. So what we provide, in fact, is material. As I said, material. It can be easy or not to deploy, and software. So we deploy software. Very interesting to have this navigation, but in fact, nobody take a day to look after all the forklifts, just to have logs, to have this alert in case of collision, in case of problem. And of course, if you are looking for an item, you can find it very easily with algorithm. Why we need algorithm? Because we have to deal with a map, and it's not outside map. It's not a Google map. It's indoor map. So it's a layer that we put with the building map, and we have the position inside regarding the scale on the map. We push that in the cloud, or we do it in local. So at the beginning, of course, we work a lot with local solution because it is intrusive a bit at the beginning, and year after year, it's become more easily to explain that the security is enough in a cloud, so we can deal with cloud or app, of course. If we provide, and we already provide an application on a Google Store, it's quite easy to deploy for operators. So I come back, of course. Our added value in IIDRE is to have this seamless continuity, GPS RTK. So we have classical technology, and we have our own made GPS RTK, and we deal with our EWB to have this less than 10 centimeter in theory, that means that in real life, we are more around 50 centimeters regarding the context, regarding warehouse. Of course, the number of engines that you are tracking, the number of human who are dealing with in a context. So it's quite difficult to keep this 10 centimeters. So we deal around 50 centimeters, and it seems to be enough. Maybe it's not for some case, but it's most of the cases it's enough for most of the cases. And as I said, we have the possible exchange. We really prefer Wi-Fi or LoRa, LoRaWAN to exchange, but we can have this if you want to exchange in a specific spectrum bands. That means that there is no collision between Wi-Fi, so it can be done with EWB. Okay, so imagine as well, put this picture. In this picture, we deal with outdoor and indoor in a very large site. And this very large site, because of fire, we have outdoor point of outdoor to have this classical exit. So that means that we have to be sure that we have all the persons. That means that if not, we have to find and we have to find who is missing, and it can be, of course, indoor. So as explained, we deal with this kind of solution. And in this case, it can be intrusive, of course, because it's linked to someone. I put another solution that we have. It's a package, material package. We provide material package, and we provide software. It's an app in this case, and we use Bluetooth to have the communication. But we use the EWB to have the exact position in an underground inspection, and we have in a picture the exact distance of the drone in real time for the operator. Another example, of course, is at this moment we have a lot of European call regarding this application. So it's to have a complete tracking solution for waste. So that means that with indoor and outdoor bins or waste, you can have the real-time location, or if it's full or not. That's enough to have the cycle. I want to talk again about the automotive sector. So ITS is Intelligent Transport System. So in this sector, we focus in position, of course, but it's position-centered position. So that means that the tag want to know his own position. And the biggest challenge, of course, is in critical area, of course, without satellite in a urban canyon, but it can be in parking as well. We need this very precise position. So imagine in autonomous vehicle in category 5 in real life, you switch between GPS, RTK, and EWB. So imagine that we need this very precise position on movement in automotive. So yeah, I want to talk about the predictive and descriptive analytics, but we are more in a platform. Of course, this data are used for predictive and descriptive scenario. So of course, platooning, platooning, it can be very interesting. So platooning is for the trucks. If you have a queue with 10 trucks in a motorway, this solution are in development at this moment. So we need a very fast communication between the first and the last engine. So this technology allows this very fast communication. We need a very secure V2X, is vehicle to infrastructure, vehicle to vehicle, or vehicle to so it's a communication, a vehicle to something, infrastructure or other vehicle. The same, we need a very fast exchange. So IIDRE, we are dealing with ITS, Intelligent Transport System, since 2015. Other example, of course, is a dock. If we want a very precise dock, so legacy for the bus is around 2.5 centimeters. So the accuracy is, in this case, very important. I talk about platooning. Platooning, we have this example. On V2E, I put other example on communication to be sure that we can have maybe double channel communication. Okay, so let's finish with the last point, maybe the last and most important, because we began with ESA in incubation. So I want to talk to you about this initial project in 2014, 2015. So it's very interesting to see that 6 years later, we are dealing with this same context. That means that at this time, we provide a seamless continuity, outdoor, indoor. So with GPS outdoor, of course, and indoor with wireless sensor network. So at this moment, we didn't use the EWB. We tried other technology. So that means that we already deal real-time locating system with Wi-Fi, Zigbee, Bluetooth, LoRa, a lot of different technologies. So we already compare the results, and now we are quite sure about the issue. So we know that we have to use the technology, each technology for not for all application, but just for the right application. So that's the old story. And at this time, in 2014, we provide in documentation this table. So I quite find it quite funny. So it's interesting to again compare 7 years before. It was done like that. So imagine that EWB already exists, but at this time we didn't deal with security, for example. But we can see that accuracy was one of the best criteria. Of course, we compare with Wi-Fi and RFID, not Bluetooth at this stage, but because we assimilate Wi-Fi and Bluetooth in 2014. Okay, so thank you for this time. So I spent time to explain. I think the most important for me is about the technology, the comparison, and regarding the use case, how it is interesting to deal with very precise position.
Thank you very much, Michel. It was very interesting. So if you have some question, you can ask them in the question box. So we have already some questions. The first one is, do you use the RTK technology?
Yes. We use the GPS RTK. RTK is to allow 1 centimeter precision outside. So we need ground station to allow this, and we design our own homemade GPS RTK to have this seamless continuity. We know it's quite expensive. It can be expensive, so we already have our own solution. Yeah. So of course we use it.
Okay. We have a question about the accuracy. Do you have the same accuracy indoor and outdoor?
No, in fact, we have better accuracy with GPS RTK. It's true. With the GNSS outside, we really deal with 1 centimeter. So it's very precise, very interesting. On indoor, it's quite difficult to keep this 10 centimeter, but yeah, depending on the project, if we have enough time, especially to deploy the infrastructure, that is really more complex. So we have, so imagine that regarding a map, you need to fix your anchor in exact position to be sure that you respect the exact distance. So to keep this 1 centimeter, you have to be sure that you put the anchor in around 1 centimeter. So it's more complex, in fact, indoor again.
Okay. And do you have a concrete example of your solution using by some customer, and what is the added value for your customer?
So the concrete solution, yeah, because we provide material. As I said, we provide the material. So the material is designed by our company, and we provide software as well. And in the material, we have two parts. We have infrastructure, and we have tags. It can be two different way to acquire this kind of technologies. That means that we can buy infrastructure and deploy just 10 tags. On 2 years after, you can buy other tags to deal with the infrastructure that you already deployed. And the software, third part, the software is how we push the data to the customer. So now more in the cloud, we push the data in a server, in a database server first, and we push log secondly with a connector. At this moment, we deal with SAP, one of the biggest ERP, and it's quite simple. In fact, we have to follow the format, that they deal with, and we push the format to the customer, and the customer takes the information and don't change his ERP, of course, and just add this information. Add the information in visualization with our software and with their own software to store the information, to be sure that they can have the information in historical data and maybe in real time to find something. So that is so it's a concrete deployment, tags, and software.
Okay, thank you very much. For now, we have no more questions. Thank you very much for your presentation. It was a pleasure to welcome you today. And I wish you good luck for the rest. Oh, of course, another question. Each time when I want to conclude, I have a question. So,
Okay.
question is, do you already have any use case in agriculture to measure land plot shape and area? Flight plan for drone, for example.
Yes, in fact, yeah, we already try to develop, but we are more in proof of concept in agriculture, to be sure. Regarding the sector, we know that some are used already. Industry, they already use, I think, in industry, all the company already use EWB, to be clear. That is the point. In agriculture, it's it's very different, because they prefer wait for a mature application, more to use different boxes. So in agriculture, we deal already with some customer, but it's at this stage more proof of concept, to compare technology or to use it in specific case. Yeah, so it's time to market is quite different. So
okay, and there are a second part. Sorry, there are a second part to the question. Is your starter kit competitive against SBAS or BAS? I don't know how to say it. BAS solution or ETICAS that might be more accurate but expensive?
Well, it's difficult to talk about competition. As I said, I don't want to have competition with other technology, because each technology answers to each problem. Our starter kit is as open as we can. That means that if you plug it, you have the log, you have the data, you can deal it with like at the command. So it's very simple to use it and to use it for a concrete project. The starter kits allow you 100 position per second and very precise position. We put inside EMU for accelerometer, gyrometer, barometer, and magnetometer as well. So yeah, with the starter kit we can touch this result. That is really the point. We know that DECAWAVE provide a lot of kit, but it's not a starter kit. It's more to understand how it's working, but it's not fair to continue with this kit for the project. And we have this small rupture between the customer who want to be sure that it's working properly with this DECAWAVE kit, for example. So they understand that it's working properly, but after that they have to change the system to take a more stable, robust product for the project. And with our starter kit, we try to provide as simple solution, but very important to have the beginning of the project. So that's explained, we call it starter kit. It's the starter of the project. So yeah, so compared to the other, it can be interesting to have this discussion to see if we can reach the position regarding the specification document or the project application.
Okay, thank you. And we have another question. So do you have some tests or experiences in greenhouse with results close to 2 to 5 centimeters?
In a greenhouse for 2 centimeters?
2 to 5.
2 to 5. Yeah, I want to say, yeah, we touch the 2 centimeters, but we know that it's quite difficult to keep it. So it depends, of course, of what we have to track, what we have to follow, if it's on the way or not, if it's moving fast or not. So it's completely depending of the project. So yeah, it's quite difficult to answer very quick. We have to study a bit the application, the specification document or the context. But in a greenhouse, of course, we already provide a solution for waste.
Okay, so this time I think we have no more questions. But last chance, if you want to ask something. Otherwise, I think Michel will be available if you have if you have the question you want to be in touch.
Yes, of course. Yeah, it can be very, very interesting to discuss about the technical part. The deployment is, yes, easy to do, but at the beginning, we really prefer to have a context to be sure that we can answer to the problem. We know that the market is huge, the market is very large for a lot of SME. So we prefer focusing in her added value. And we know that because we deal with other integrator and we work with Bluetooth and Wi-Fi asset tracking company. Yeah, so it's very interesting to discuss about in fact, the technology to be sure that we can have the right answer.
Okay, thank you. So thank you very much for your presentation. We're very happy to have you today. And good luck for your upcoming activities, and bye-bye.